class already we have discussed about the motion. What is motion? The simple movement of an object is called motion. So today I am going to discuss about the graphical representation of motion. That means how we can represent motion on graph. So graphical representation of motion. Listen, already we know that based on speed, motion classified into two types. One is uniform speed, another is non-uniform speed. Non-uniform motion or speed. Non-uniform motion, there is uniform motion. Okay. What is uniform motion? What is uniform? Motion means the distance covered by an object per unit time. But here uniform motion means the equal distance covered by an object in equal interval of time. Non-uniform means not equal. That means the distance varies. The distance varies in equal interval of time. Okay. So how can you represent uniform motion on graph and non-uniform motion on graph? Listen, before going to represent motion on graph, first we should know three factors: speed, distance, and time. Time always goes on. So time is always constant when you represent motion on graph. Okay. Only distance and speed varies. So when you represent motion on graph, there are two types of graph. One is distance time graph, another is speed time or velocity time graph. So first, let's talk about distance time graph. For distance time graph for uniform motion. Suppose let's take an example. Here is a point. Here is another point. A object start moving from point A to B. When the object start from point A to B, it covers. Suppose it started at 7 a.m. The object moving at 7 a.m. from point A. At 7:15 a.m. in 15 minutes the object covered 2 kilometers. That means in 15 minutes the object covered 2 kilometers. Suppose cover 2 kilometers. In next 15 minutes at 7:30 a.m. the object also covered 2 kilometers. In another next 15 minutes at 7:45 a.m. the object covered 2 kilometers. Same in 15 minutes. At 8 a.m. also the object covered 2 kilometers in next 15 minutes. So here interval of time is 15 minutes, 15 minutes, 15 minutes. In each interval of time, in each 15 minutes, the object cover 2 kilometers. So that is called uniform motion. In uniform motion, keep in mind, speed is always constant. So let's draw this uniform motion on distance time graph. Here's x axis, this one is y axis, timing always goes and time is always constant, so its x-axis is time. Okay, and this one is distance denoted as d. Okay, so this one origin 1 2 3 4 5 6 7, and this one 8. Okay, 7 a.m. and 7:15 a.m. In 15 minutes, the object covered 2 km is 2 km. Okay. In next 15 minutes, it covered 2 kilometers. 7:15 a.m. 2 2. Next kilometer total covered 4 km. In 7:15, object cover 4 km. At 7:30, the object cover, sorry, 2 kilometers, 7:30. This one is 7:30. Cover 4 kilometers, 7:45. It covered 6 kilometers. Okay, covered 6 kilometers. At 8 p.m. it covered 8 kilometers. Here interval of time is 15 minutes, 15 minutes, 15 minutes, 15 minutes. And in each interval of time, the object covers 2 kilometers, 2 kilometers. Okay, is 2 kilometer, 2 kilometer, 2 kilometer. Okay, 2 kilometer, 2 kilometer, 2 kilometer. That means 2 kilometer, 2 kilometer, 2 kilometer. Okay. So we conclude that when the object moves with constant speed, when we represent on distance time graph, the line is always straight line. Okay. The uniform motion is always straight line when we represent on distance time graph. So uniform motion is always straight line. Okay. And now let's talk about non-uniform motion. Non-uniform motion means if the object cover more distance in less time, or the object cover less distance in more time. Either cover more distance in less time or less distance in more time. Non-uniform motion. Suppose in 15 kilometers the object cover 2 kilometers. In next 15 kilometers, the object covers 3 kilometers. In 5 minutes, it covers 3 kilometers. In next 5 minutes, it covers 5 kilometers. In next 15 minutes, it covers 7 kilometers. 5, 15, 17 kilometers. 17 kilometers. So 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. Suppose 14. 5 kilometers. Okay. Means at 7:45, from 7 a.m. to 7:45 a.m. That means in 45 minutes the object cover only 10 kilometers. Okay. 10 kilometers. This is x-axis. In first 15 minutes, it covers 2 kilometers. Point is here. In next 15 minutes, it covers 3 kilometers. That means at 7:45, that means he covered 5 kilometers. So you have to take point here 5 and 7. In next 15 minutes, it cover 5 kilometers more. That means it covered 10 kilometers. Keep in your mind, it's not possible to draw on a whiteboard. Okay, it will be you will get a better result on graph paper. So, if the object cover more distance in same interval of time, keep in your mind the distance time graph line always goes towards distance because it covers more distance. When it covers more distance, the line goes towards distance. And another thing keep in mind, non-uniform motion, when you represent non-uniform motion on distance time graph, it always shows curved line. Okay, if the object covers less distance in same interval of time, that means here speed is less. Suppose the object cover 5 kilometers in first 15 minutes, then it cover 3 kilometers in next 15 minutes, then in next 15 minutes it cover 2 kilometers, next 15 minutes it cover 1 kilometer. Okay, let's represent when the object cover the less distance in same interval of time. In first 15 minutes it covered suppose 5 kilometers here. Okay, in next 15 minutes it covered 8 kilometers. So 3 kilometers, that means 8 kilometers. Okay, in next 15 minutes it covered 2 kilometers, that means 10 kilometers. In next 15 minutes it covered 1 kilometer. Okay, so gradually the graph line always placed towards or goes towards the time axis because it covers less distance. It is not possible to draw on a whiteboard. It is better to represent on graph paper. How can you represent same uniform motion and non-uniform motion on velocity or speed time graph? You can say speed time graph or velocity time graph. Okay, speed time graph or velocity time graph. Keep in mind, distance time graph we focus on distance, but in speed time graph, speed is equal to the velocity, but we consider velocity only when the object is moving in a straight path. Uniform motion, when you represent uniform motion on speed time graph or velocity time graph, x-axis, this one y-axis. So time is the x-axis, and this one is speed or velocity. Speed or velocity. Okay. Same thing. For uniform motion, an object started from a point A, start moving from point A to B. Uniform motion means the object covers same distance in same interval of time, and in case the speed is constant, suppose at 7 a.m. the object started from point A at 7 a.m. 7:50 a.m. 30 a.m. 7:45 a.m. That means the object moving with speed 2 kilometers per hour. Okay, we don't know what distance did it cover. Next 15 minutes, same it will cover. It also goes with same speed, moving with same speed. Next 15 minutes, moving with same speed. When you represent uniform motion on speed and velocity or time graph 0, 7 a.m., 7:50 a.m., 7:30 a.m., 7:35 a.m. and 8 a.m. 1, 2, 3, 4, 5. 7:15 a.m. to 7 a.m. to 7:15 a.m. Speed is 2 kilometer. In 15 minutes, his speed is 2 kilometer per hour. In next 15 minutes, at 7:30 a.m., its speed doesn't change. That means same speed. Also 2 kilometer. Next 15 minutes, same 2 kilometer per hour. Next 15 minutes, 2 kilometer per hour. When you represent uniform motion on speed time graph or a velocity time graph, then the line is parallel to time axis or x axis. Uniform motion, the line is parallel to x or time axis. The speed time graphical representation of non-uniform motion. Non-uniform motion means speed varies. So let's take an example. Suppose Mr. Sharma started from point A at 7 a.m. After 15 minutes, started from point A with speed 2 km per hour. Okay. Then after 15 minutes, also its speed varies. Then at 30 a.m., he saw his speed is 5 km per hour. Then after 15 minutes, also its speed changes. It becomes 7 km per hour. At 8 a.m., he saw his speed is 9 km per hour. So how can you represent when the speed varies on speed, velocity, speed or time graph? Okay. In 15 minutes, his speed is 2 km per hour. Okay. At 7:30, he saw his speed is 5 km per hour. At 7:45, his speed is 7 km per hour. 8, 9 km per hour. The speed gradually increases towards the speed. The graph should be curved. Non-uniform motion. Motion if with increasing speed. The increasing speed graph curved line goes towards speed or x-axis. Okay. If the speed decreases gradually, then the curved line goes towards y-axis. In doubt about average velocity. Average velocity. Average velocity. Average velocity. Listen, let's take an example. Suppose Mr. Sharma driving his car with speed 40 km per hour at point P, and he saw his speedometer at point Q. At point Q, the speed of the car is 80 km per hour. Till here, initial velocity, the speed of the car, initially the speed of the car is 40 km per hour. So it is called initial velocity, initial velocity, which is denoted as u, and here he saw at point q the speed of the car is 80 km. This is called final velocity, final velocity, and which is denoted as v. Okay, when you find out the average velocity with distance and time, when you find out the average velocity, then you have to find out the displacement. But here initial velocity given, final velocity given, there is no distance given. But when you increase speed from 40 km per hour to 80 km per hour, it takes some time. Suppose it took 15 minutes, suppose it took 1 hour or 2 hours, suppose 2 hours, Tell me, started from 40 km per hour and we saw 80 km per hour, that means the distance between PQ is 100 km per hour. Okay, suppose, leave it. So what is the average velocity? Average velocity means initial velocity plus final velocity by 2. Initial velocity plus final velocity by 2. 40 km and 80 km. 40 plus 80 to 120 by 2. 60 km per hour. That means it here speed varies. Still the car took 2 hours to cover 100 km because the distance between P and Q is 100 km. We find out the average speed. If the car having constant speed with 60 km per hour, also it will take same hours, same time, but 2 hours to cover 100 km. End out. Okay. Let's talk about what is acceleration. What is acceleration? Acceleration means what? The rate of change of velocity. The rate of change of velocity per unit time. Okay. Tell me, when the speed is 40 km per hour, 40 km per hour, and the final velocity is 80 km per hour. Acceleration means, also have you seen accelerator in the vehicles? The change of speed, change of velocity. When you change your speed, also you have to roll down your accelerator in the vehicles to increase speed. And also when you roll off accelerator of the vehicles, then your speed gradually decreases. So the change of velocity, change of speed is called acceleration per unit time. Here acceleration is 40, 80 minus 40 by time 2 hours. That means 20 km per hour. So acceleration, what is the acceleration? The final velocity minus initial velocity by. So here acceleration is how much? 80 minus 40 by 2, that is equal to 20 km per hour square. Here acceleration is positive. When the speed increases, we call it acceleration. Suppose the initial velocity is 40 and final velocity is 20 km per hour. That means speed decreases. It took, suppose 1 hour. So final velocity 20 minus 40 by 1, that means minus 20 km per hour square. When the acceleration negative, also it called, that means negative means the speed decreases, also is called deceleration or retardation. Retardation. Okay. If the acceleration is negative, it is called deceleration or retardation. Okay. And now, so let's solve some problems which are related to acceleration, average velocity, average speed, speed, distance, time. Okay, let's start. Listen, there is a question on 120-kilometer track. A train travels fast 30 km of uniform speed 30 km per hour. How fast must the train travel so as to average speed 60 km hour for the entire track, the entire journey? When we solve mathematics or any problem, first you have to segment or separate the each lines. Okay, on 120-kilometer track, here is a track. This length is 120 kilometer. A train travel 30 kilometer of uniform speed. Fast 30 kilometer. The train travel fast 30 kilometer with speed 30 kilometer per hour. When the train covered 30 kilometer, then it has to cover 90 kilometer more. Okay. How fast must the train travel so as to average speed 60 kilometer per hour? Tell me what is the average speed given? Average speed given. Average speed means total distance by total time. Total distance here is d1 plus another segment d2 by total time. So here the train covered 30 kilometer in with speed 3 kilometer 30 kilometer per hour. That means a train covered 30 kilometer with speed 30 kilometer per hour. So let's find out the speed given, find out the time. Here speed given, d given. Can you find out the d1 given, s1 given? Can you find out the t1? t1 means d1 by s1, 30 by 30. That means 1 hour. That means 1 hour. Okay. And next, come to this segment, this part. Distance given. Okay. Distance given, but you don't know the time. But don't know the time. Let the distance, the train cover 90 kilometer in x hours. In x hours. So average speed is total distance by total time. Here we got the time t1, t2. Average speed 60 kilometer. d1 first covered 30 kilometer plus next 90 kilometer. We covered first 30 kilometer in 1 hour. So 1 plus we have to find out the 90 kilometer covered in x hours. X. So do the cross multiplication. 60 whole into 1 plus x equal to 120. That means 60 plus 60x equal to 120. That implies 60x equal to 120 minus 60. That means x equal to 60 by 61. That means the train has to cover 90 kilometer in 1 hour. Okay, 90 kilometer in 1 hour. Well, how fast must the train travel so as to average speed 90 kilometer per hour? 90 kilometer per hour. Distance, time given. So what is the speed of the train to cover 90 kilometer. 90 by speed of the train to cover 90 kilometer. Distance by time 90 by 2 1 hour. So 90 kilometer per hour. 30 plus 90. What is the average speed? 30 plus 90 by 2. 120 by 2. You got the 60 kilometer per hour. And out. Okay. But the another question.